Hello all, we are here for the lesson number 30 for this VariCAD training course, and this lesson is called Solving Problems in 3D Environment. We talked a little about this already on the previous lessons, but we are going to go a little deeper under this topic in this lesson. So I will use the exact same file we used on the previous lesson. So do the open and import the same step file with the same part you already know. Okay, so basically what we want to see here are some common mistakes that we can get in either import files, step files, or working with VariCAD. So the first thing that we want to see is about the Reparation Tools under the Objects menu. Okay, Reparation Tools, we have a couple of functions here, and the first very important thing to let you know is that these tools are supported for step files but are not supported for the IGES file, which is already not very commonly used as were a couple of years in the past. So the first thing is, we talked on the previous lesson that when we import parts through the step, we may get some errors. This is not common, okay? And in this particular case, you can see that I have a perfectly closed part without problems, but I can get several problems here. One of the problems, we saw it already, it was to get an open part, and then we have to deal with the several levels of parts, missing patches, closed shells, whatever. Okay, there is another level of problems which has to do with the normals, and we also saw a little about this, and we will try to do something now. It is possible, not very common but possible, to get on the import of a step file to get one or more of the surfaces of the part with a reversed normal, and then we can have problems. Okay, so I will simulate a problem and we'll delete this and we'll convert this to missing patches. And what we've seen in the previous lesson was this is a solid without the problems in terms of normals. That is why we can see these different color mode, the black for the interior side and the gray for the outside. But what we can get sometimes, and when that happens, it is a problem of the software that is writing the file. Okay, what we can get is that the normals are inverted, and then we may need to get to these two functions here to reverse all normals in case of everything is reversed, or if it is just one of the surfaces, one of the patches as we call it here, we need to revert that particular one. So we already show it, but again, reverse normals at selected patches. So we are going to click one of the patches and just do the OK, and that's it. Okay, everything was reverted with the exception of this one. Okay, I will not simulate what we will get with this, because in this state now we will get mistakes, because the normals should be all for the same side, outside or inside. It's not this the case, but just to show you that if that kind of thing happen, we may have to revert one or more or all on those functions. So I'll do the undo again. Okay, and that's it. The solid is already closed again. There is another kind of mistake for several reasons if we create one solid, and we also done thing like that yesterday, so I will create a very simple one, okay, to simulate this. So I'm creating a cube, very normal one, okay. If something happens during the work process, we can make blendings, intersections, or Boolean operations with other solids, and it may happen that after we do something, the solid will get errors and you cannot work anymore with the solid, okay. It may happen in particular conditions, but it may happen. So what happens now is that when we are working normal workflow, I already show you that it is possible, and we have some history attached to each solid, and this history allows us to edit whenever we need or want to edit the characteristics of the solid, okay. But when we reach a state where there is a mistake, we may need to avoid to decompose the solid in single elements, and probably after from that period on we will not get any possibility to work properly with that solid. So we may need to do this kind of thing: convert to imported object, destroy, creation history, okay. So we do this, we destroy the history, but at least we delete the mistakes. And from now on, when we try to do something to this solid, the history will be created from this moment on. So if we try to edit the solid now, it's not available, but the thing I've done in this case, a chamfer, it is possible to be edited. So this is another very good possibility, and it is this function exists for these particular cases. There are a couple of other functions also here, and are the last that I want to show you are these four functions here. First, these two: regenerate all 3D objects and regenerate transformation of all 3D objects. Sometimes we get mistakes again on the solids we have inside, and this is can occur for several reasons, but the important to retain to you is that when we start to get problems, mistakes, functions that do not work, we may go to these two functions, and they are very similar. They will rebuild and clean some internal mistakes, that mathematical mistakes that the objects may have. So you'll get this kind of function, and as you can see, in case of internal solid errors, corresponding solids will be exploded into single elements. So if it is possible to save them without decompose them, it will be done. If not, it will be split in single elements, so that the mathematical expressions of each element is simpler and possible to work with. So okay, now it was redone, okay. So the history maintains. In this case there was no errors, but at least it cleaned my solid. Both of the functions are very common and very easy, and this regenerates the 3D object in terms of the mathematical expressions, the internal structure. These below do the exact same thing, but will do an additional thing which has to do with the position in space and the position regarding the other solid. So basically it will make you the same thing, but you can use them, and it's not very important at this moment to retain the exact case in where you can use one or the other. Just that if you have errors, try one or the other, and it will solve you some of the issues, okay. So these are done. To end this lesson, just want to show you two more functions: file checking, file recovery. There are some situations where due to hardware failure or to power failure, when we are trying to save a file, you can get files with errors and you may get problems when you try to open them or something like that. So you may try to do this file checking, okay, and this will analyze the files. So please take the note that this is for files saved in VariCAD 2014 or later, okay, and they will analyze a couple of kind of different types of errors. So I will try to use this in one of the example files I have. It doesn't matter, and it says no errors found in file data. This is for analyzing, and you have the other one for recovery in case you have problems, okay. It is recommended to close very easy, and you can, if possible, to turn off sections, because sometimes sections will give problems, okay, and you'll get unsuccessful results applying this file recovery. So again, I will try to use it on the same file just for example, and it is done, okay. It will open, and this had no problem, but if it had problem, it had made the recovery to the file, okay. This is not perfect, but at least sometimes if you have a file with a lot of work already, you can solve many of the issues, or you can recover some of the things you have, so instead of losing everything. So this is a shorter lesson dedicated to this solving problems topic, and we finish it. So next lesson we will see about creation of solids, which is one of the main aspects of the program in 3D side. So hope to see you then.